what happens next, and let's dive into the networking bit. So something that Carl briefly mentioned, he said, well, what's going to happen, like really, is that you need networking, as a more advanced form of communication and really linking things, and that's something that sort of sits in the middle of frontier cybersecurity, or cybersecurity post-quantum, and also quantum computing, because that's the only thing that's it's going to be enabling really large quantum computation one way or the other. And so it happens that photonics is really the only working glue there right now that can be done. But before that, let's just step back a little bit and have a look at the utility and the value that current digital technology offers to us. So this is a map of internet, as it's called. So it's basically a collection of all public IP addresses and different continents and networks. And I think it just shows the scope and the scale and like the level at which it's penetrated our lives. And so what I'm alluding to is that quantum technology not only supplements this, but it needs to offer better utility as well. And here's a little experimental example. So, it's not a real one, it's a mental exercise for you. But let's say, we have what's underpinning that big network is the fact that we have undersea fiber cables. So the vast majority, 99% of the traffic goes there, and it looks like this. And today, you can have cables that take 250 terabits per second, across Atlantic, easy. And then let's take an average commercial QED system at a distance of 100, 150 kilometers, and you'll end up having the fact that if you wanted to just simply get that speed out of the systems, you'd need to populate 2.5 New York cities with racks of QED systems. And it just shows that, it's a great start, but it shows the utility there. We still need to work on this. And in our view, the best way to get that utility is obviously to, you need to increase the density and power efficiency of everything. And the best way there is same as we've done already with digital, is it's about foundry manufacturing. And in this case, photonics is really the key to everything. And you have to do it in a hybrid way, because you have multiple different functional elements in quantum, and they all need to be maximized in their efficiency. So you have no chance of compromising on losses, because you only have one photon, or you have only one particle or one qubit. The next thing is obviously it needs to sit in a small form factor, all of it. So all control, everything. And I think everybody in this virtual room already said, well, it's a rack, it needs to fit in there, but like computers as well have to do that. And finally, obviously, it needs to sit on existing infrastructure. So you cannot really take all the fibers out. You cannot reinvent in an instant all of the manufacturing. And so all of these things is what we're doing, is ensuring that it's all kind of compatible and low power, low volume, low swap, if you want. And so if we take the frontier cybersecurity networking angle of what we're doing, so we're engaged in a number of activities, including some of the more advanced QED protocols. But I've just outlined some of the things we're doing in terms of hardware services and kind of rolling that out to the customers. And we do like to work with people at early stages when they're trying to explore for themselves what is the roadmap and trying to help to build them this. But I'm going to give you a few examples of things that really important in this, and one of those is the generation of quantum states. So it needs to be deterministic. That means that whenever you send a trigger, you push the button, it definitely is generated. I think we take it for granted in digital, like that it is what it is, but actually in quantum, it's not so much. And that's a very, very difficult thing to do, and that's what we're doing. Moreover, you need to have, in order for that to work in a quantum way, to have the quantum interference, to have the scale, all of those features, all of those photons, all of those qubits, they really have to be physically indistinguishable. So they can have quantum entanglement and interference in between them. And that's, again, a very difficult challenge, and you haven't seen that in digital, but we've done it. And finally, you don't need any noise, because any noise means massive errors. So you cannot stand any kind of a background noise or something like this. Well, in principle, it exists always, but you need to minimize that to an absolute zero if you can. And we've done a very, very good job at that front as well. So now let's look at the little challenge actually there in Quantum, because we said networking, we need to link things up. And there's a bunch of applications in Quantum overall, including computing and communications that are dressed in optical spectrum. And it's, that's what you really call a spectrum. Like, things are really on a spectrum. So you've got to address, everything from visible, even ultraviolet, all the way into infrared, where the telecom sits, and then there's also free space communications. And so we focus on some areas which we feel are going to be kind of where the strategic convergence is going to happen for multiple reasons. But in particular, obviously, that's a fiber infrastructure and C-band, and also near infrared, where a lot of other things are happening. And so, and what we're doing, so here's actually things that we started selling in November last year. So we rolled out to market our single photon sources as the most basic form of that quantum state generation I was talking about, with very high specs. So there's a choice of different housing modules for all the control, all the cryogenics. So everything literally sits in that box. So you're not talking about those IBM kind of chandeliers that sit somewhere in a huge dilution refrigerators. You need some control, you need some custom lasers. That's all done. And here's a couple of examples how you can configure this system. To be more performant, to be less performant, to look in different wavelengths. Well, just give us a call and we'll sort you out. Whatever you're doing, is it an experiment? You're building your next generation network? You're building a satellite link? And speaking of the networks, well, here's the example of how you can use this. We can go up to 10 nodes, but well, this one is for 4. Again, simple couple of boxes in your rack, and you're sorted for your 10 node or 4 node network, easy. And it can be standard QED, it can be entanglement distribution. You tell us, we'll get it to you. So there's more things to come. So watch this space, but I think that's already a great start. And hopefully we can help you as well with something. So thanks very much.